Our next set of topics is going to cover enumeration types in Java. So let's get started by adding some constants, such as, for instance, I can have public, static, final, int, just say final right here, final int, and let's say that this is for an employee. We can say full-time. So this will be the types of employee, and we'll just arbitrarily set it equal to 0. So now I can create additional employee type constants in my code. So this will be a part-time, and this will be a consultant, like this. So now I can create an integer employee type and initialize it with some of these values. That was the intention, to keep everything descriptive as much as possible. By the way, let's just make these values unique, 0, 1, and 2, for example. And now I can write some business logic based on this switch. Create a switch, and this switch will be on this employee type. And then, of course, I can have my case labels that correspond to these unique constants. Right, so I'll just use a break statement right here. And so we can then make it something that we want to do with respect to these different type of employees. So this is a nice way of organizing our application. So for instance, we can just say system.out.print. I'll just use print line, and I'll print the employee type. So of course it will be just printing an integer, but just something to demonstrate the application logic. So this is fine. It's quite readable overall. But there is one significant problem in this organization, that this employee type is an integer, and therefore it can accept just completely arbitrary value. So it does not necessarily break this switch statement, right? We could add a default label and do something with respect to, something outside of the range 0, 1, and 2. However, perhaps it would be a great idea if we could just completely enforce the fact that this employee type cannot be initialized with 123. It just has to be something only predefined based on this set of constants that we want to use in our application. So that means that we need to switch from an integer to something else, and this is called enumeration. So enumeration basically restricts the set of values for this integer. It will still be behaving very much like an integer, to only predefined set of constants. So this is enumerated type or enumeration, and it's just a set of named constants. So how can we do this? We can go to our package, and we can right click, and we can say new, and you see that on this list we don't have an enumeration. But so we can actually create a class and change it to become an enumeration. It's not very difficult. But under other, there is an enumeration type like this. Okay, so what I'm going to do here, I'm going to go next, and just like a class, because this will be defining a very specific data type in our application, it needs a name. So I'll just say employee type Okay, so name it employee type and click finish. So you see that this looks very much like a class, and it's placed in a Java file, but its type is enumeration. So this is not a class, this is an enumeration. And here, if I want to generate a set of name constants, all I have to do is just type them like this: full-time, then part-time, and then consultant. Right, so this will be a set of constants. You see that they're actually separated by commas, and the very first one will be by default assigned the ordinal value 0, and this will be value 1, and this will be value 2. So this is how it's defined. So let's move it to the next document tab group. I'll just close this project right here, and let me make some updates in my code. So I'll comment out my original declarations of my constants, and instead I'll try to rely on this employee type. So this employee type will replace the integer. And notice how this employee type now begins to resist this and will say basically the types are incompatible. You cannot just take and grab an arbitrary integer and assign this to employee type. You better go with one of these. So we'll just use full-time, right? So we can use one of these constants. Just like this, but unfortunately here it has to be qualified. So now we have to say employee type and whatever, consultant, full-time, part-time. Now, of course, I have to modify my switch statement, and you would think that the case labels for my switch statement would expect this, right? So for the part-time consultant, the same. But it's interesting that what it tells me here is that enum switch case label must be unqualified name of an enumeration constant. So the switch here becomes so restricted that it just doesn't want even this. It just wants this. Okay, and so that's how we can redo what we did originally. Okay, and so this now again the main number one benefit here, that this employee type is no longer an integer. It is one of these enumerated values, one of these constants. So let's actually run this code and see what happens when we run this code. Right? So of course I initialize it with full time. When I run it, it displays full time. So by default, enumeration converts itself to string that corresponds to the name of this constant. Right? So if we try to convert employee type to string in order to print this, you can see what happens in the output. It does not print 0, 1, 2, 3, 4, 5, those ordinal values. It prints a full-time or part-time. It prints the name of the constant. So that's the behavior. If you don't like this behavior, you can, if we still need to display 0, 1, and 2, we can call Ordinal Method, which is the method that comes with enumeration. So each enumeration has Ordinal Method available for us to use, and this should display the actual values, right? So for the full time, I'm expecting this to be 0, this to be 1, and this to be 3. So we can, place this in a separate method. We could say private static void and say print employee data, whatever, and we'll just actually it's print employee type, because we're only working with the type. We don't use any classes here. And of course the method will be expecting this employee type as a parameter right here. Okay, so we'll just do that. And this is the this is our method, and here I'll be using print statement. Okay, so this is print employee type. Again, copying and pasting. I can just go source format to keep everything nice and neat. So I'll move the switch. Okay, I'll move the switch. Actually, I'll move this entire switch into this method. I think that would be what I want to do. And so here I can take my employee type and try different types. Try part-time like this, and also try consultant. Change it 3 times to all of these values that I have, and each time I will call this method. Right, so call this method and pass employee type to this method. And we can print this 3 times. And right now I decided not to print the default version of converting our enumerated employee type to a string. Instead, I'm just trying to print the ordinal numbers. So you see that the values assigned by the compiler to these constants is 0, 1, and 2. So if you need to obtain the actual 0, 1, and 2 values, you call the ordinal method, and this is what we're trying to demonstrate here right now. All right, so this is the look and feel of enumerations, and just to say a few more things about this. Enumeration can be specified in a separate file. That's exactly what we did with our employee type. It can be placed in a related class file, just like that second class we had in our previous video. And we can also nest enumerated types inside classes, so that we can basically place it inside some class, just like we did with this set of named constants that we originally created, which were still integers. Right, so just likewise we could move this right here and keep it internally inside our class. So the syntax, you already have seen my syntax is basically just like this, and this is an example of a shipping type. And again, the shipping types will be restricted to the set of constants. Of course, this can continue to grow and so forth. Of course, remember, with these constants, we kind of have to maintain these values. Here, these values would be assigned automatically by the compiler, because it knows that it's an enumerated type, and all of the constants do require a specific ordinal number. So those will be assigned automatically, which is very nice. It's just all automated for you and all very reliable, because each constant will be automatically unique. So this is more code that, by the way, here, instead of using a switch, I've tried to use switch to demonstrate essentially, try to decide which type I was given, and just using a switch statement. But here there's an if statement that pretty much compares enumerated type, which is shipping type. Here just uses the double equal sign to compare the shipping type that was given to us to a specific enumerated constant. So if you use an if statement, it has to be fully qualified. Fully qualified means that it requires the actual name of the enumeration and the name of the constant, just like this. In the switch statement, you've seen that the compiler doesn't like fully qualified name. You just use the name of the constant without the type name, like this. So there is the name. Okay, so let's try to print names now. Okay, so there are names of these things, and if we run this version, you see that this simply prints essentially the name of the each enumerated constant, and so this can be used successfully for debugging, right? So, but we can redefine conversion to a string. Okay, so we can try something like this and basically use the same technique like here, and we can say public to string, right? So we can just let's do this like that. So we'll override this toString method, and again we can use the same technique. So right here we can use the same logic by applying a switch statement. And instead of switching on some kind of type, we have to say this ordinal, right? So we can obtain the ordinal number from here. And let's just make sure that we format all the source properly to be able to fix all problems right here. So here, incompatible types. So this is an ordinal, so this is now converted to an int. So I'll just replace, let me see if I can try this ordinal like this. Unfortunately, in the case label, it's not going to let me do that. So I'll just use, instead of the switch, I'll just use an if statement. It will be easier, I think. If this ordinal equals full-time ordinal, then I can do this work, and I'll just then else if, we'll just copy this again. If then we are working with a part-time, we'll do something else, and finally we'll do an else like this. And what I'll be doing, because I'm converting to string, I will return full-time, return part-time, just like this, and return a consultant. Okay, so something like that. Okay, so FTPT and consultant. So let's see if everything fits together. So this here tells me that I think what we need to do is we need to add the semicolon in order to be able to provide additional methods inside of our enumeration. So now this looks okay, and we'll switch back to, like, we'll just run with employee name first. Okay, so the name method still continues to return the names of the name constants, but if we get rid of this and we'll be just simply converting the enumerated types that were given to us to string, I'm expecting that this method will be invoked for us. And yes, so we are getting the results of FTPT and consultant as I as I redefine the toString method. So this gives you a little bit of extra flexibility with what you can do with these enumerated constants. They're just like behaving a little bit like class, because you can have methods here, but the behavior is a little bit restricted to just manipulating constants, converting constants to strings, and generally you can sometimes rely on ordinal numbers, sometimes you can rely on just conversion to a string. So here these things can be converted to ordinal just because these ordinal calls are static and don't require creation of any instance of them. So this is all nice, but sometimes just like with an integer, you would want to define specific unique values here. So maybe it's 10, 20, and 30, and not necessarily 0, 1, and 2. So how can we do this in enumerated type? So that's going to be our next video.